All right, good morning, good afternoon, good evening, wherever you are. I hope that you are having a wonderful, wonderful day. I'm going to try to take just a short amount of time here to kind of go over just a couple of the formulas that we've already talked about, but I want to make sure you guys know how to apply them. So pay attention. I'm going to go over this quickly, and then when I'm done, hopefully you'll know how to do the homework for tonight. So here's what I want to do. In front of you, you see some of the equations that we covered the other day. Now, I don't believe that we put these on your Chapter 3 vocabulary, and if you haven't yet, find a spot on your Chapter 3 vocabulary to go ahead and put down this information. Now, you may want to check your Chapter 3 vocabulary packet. I believe that regular polygons is already on there, so you won't have to rewrite that down. The reason I have it there is because I want you to remember or to review what that means. So, the n minus 2 times 180, remember the other day we derived that, okay? We had a chart that we made up and we did that. So that's the sum of the interior angles of any polygon. The regular polygon, again, all angles are the same measure and all sides are the same length, okay? And so we will be looking at these type of polygons a lot later on in the year, actually. The formula n minus 2 times 180 divided by n is one interior angle of a regular polygon, okay? And so you'll see some problems today that need that equation. 360 is the sum of the exterior angles of any polygon. I'm going to be honest, this is probably one of the few sections or chapters that we're going to use that concept along with the next formula. But still, it's something that will help you solve a couple of the problems I'm going to give you in the next couple of days. 360 divided by n, obviously if every angle is the same measure, you can go ahead and divide by the number of angles or number of sides, 360 divided by the number of angles or number of sides, and that will give you the measure of one of those interior angles, okay? So, keeping that in mind, let's transition. If you haven't copied those formulas onto your vocab packet, pause it and go ahead and do that. But I'm going to move on to the worksheet here, the half sheet of paper, so that you guys understand what we're headed and what direction we want to go. So in numbers 1, 2, and 3, it says this: if the following figures are regular, meaning regular polygons, determine the values of each variables within each figure. Okay? Well, here's what I'm going to do. I am going to take a look at number 3 with you guys. Okay? And try to help you with this. Now, what I want you to visibly see is that in numbers 1, 2, and 3, all the sides are all the same length. So, is that going to work? Oh, you know what? Let's see here. My board's not working. Let me pause this for a quick second. All right, I believe I've got it going now. Let's see here real quick. Oh, there we go. Okay, so if I go ahead and mark all of these sides congruent, that's what I visibly want you to think when you think regular polygon. Also, all of the angles congruent. Okay, so there you go. All right, so the question I would first want you to ask yourself when looking at number 3 is this. Excuse me. Which formula would I want to use in order to figure out what A is going to be? Okay. Now, A is only one of the interior angles of that regular polygon. And so I would hope that as you look over the formulas that you wrote down just a moment ago, you would want to use the parentheses n minus 2 close parentheses times 180 divided by n. Okay. And what is n? It's the number of sides. So as we look at this pentagon, there's 5 sides there. So I'm going to go ahead and do this. 5 minus 2 times 180 divided by 5. Okay? And you'll want to work that out and see if you can figure out what angle A is going to be. Now, as I've told you guys in the past, if you, by chance, get a number here, let's say you get like 20 degrees for angle A, you know that's not right. Okay? It's an obtuse angle. It's got to be greater than 90. And so, as you work this out, let's see here, 3 times 180 is 540, divided by 5, that gives you 108 degrees. So this right here is 108 degrees. That's angle A. Well, that's obtuse, that's a good thing, Angle A is definitely obtuse. Now for angle B, you could do one of two things. Actually, you know what? Let's just go. Angle B is an exterior angle. Okay. Which formula on your sheet helps you to find one of the exterior angles of a regular polygon? Well, it's 360 divided by n, or the number of sides or number of angles. So 360 divided by 5, if we work that out, gives us 72 degrees. Okay. And so as I plug that in, something to think about, if it's not already obvious, is this. The interior angle and the exterior angle will always be supplementary. So I technically could have found this angle first and then went ahead and did the supplement of that, so 180 minus 72. Or I could have found this angle first and went ahead and found the supplement of that. Okay, and so that's just a shortcut you can use. All right, but again, I want to make sure that you know how to figure out the measures of those angles. Okay, so one of the things I'd like to give you credit for on the next time we're in class is actually answering numbers 1 and 2 correctly. Okay, now here's what I'm going to do for you, but I want you to show the work and how to get that. I'm going to give you the answers for X and Y here, so you can double check yourself. All right. And then I would like you to show me the work for those answers, and that's how I will give you credit the next time we're in class. So the answer for X is going to be 120 degrees. Okay. And the answer for Y is going to be 60 degrees. Okay. So you want to show me the work for that one. And then with this one, number 2, that has 2, 4, 6, 7 sides. Remember what is the 7-sided polygon called? Heptagon. Hopefully you got that right. Okay. N in this figure is going to be 51 and 3/7 degree. Okay. So again, show me the work for both of those, and I'll give you credit for that. I want to move down to one of the next ones. So let's actually take a look at. Let's go ahead and do number 4 down there. Okay. So as I look here, I wonder if I can just scroll down here. There we go. Number 4. Sweet. Don't even need to go to my computer. In number 4, it says this. The following figures will be irregular. Okay, you can tell that, and all the sides are the same length, and all the angles the same measure. If this is true, determine the measure of the missing angle within each figure. Okay? Now, in order to do number 4, we are going to have to figure out what the sum of the interior angles will have to be. Well, how do we do that? Well, we're going to use that formula that we first derived a couple of days ago, which is the n minus 2 times 180 formula. So n, in this case, there are 5 sides. Again, this is a pentagon. 5 minus 2 times 180. Okay? Now, as I mentioned a moment ago, the sum of those interior angles is going to be 540 degrees. Okay? Now, how does that help us out? Well, that's the sum of all those angles. And since I know 4 out of the 5, I can just go ahead and set x equal to 540 minus 91 minus 160 minus 100 and minus 80. Okay? And so from there, if you just go ahead and figure out what that's going to be, you're going to get x. Okay? So in this case, x is going to be 109 degrees. And as I look up there, x is definitely obtuse, so I'm happy with my angle measurement there. Okay? So here's what I'm going to do. I'm going to do the same thing with numbers 5 and 6. I want you to show me how to go ahead and solve for those two problems there. So again, x for number 5 is going to be 133 degrees. Show me how to get that. Okay? And k is going to be 127 degrees. Okay? Hopefully you heard that as opposed to writing it down there, 127 degrees. Okay? All right, now, let me write that one more time. 127, so much nicer. All right. Let's go to the back side real quickly here, and let's take a look at what we have left over for our work here. So taking a look at, you going to go for me? No? Oh. I don't know what that was. All right. If we look at the next problem there we go. It says determine the value of x within the given figure. All right. Well, we got that pesky pentagon again. We need to figure out what x, the measure of x is going to be. Well, it's going to be very similar to what we did on the previous problem because, again, this isn't a regular polygon. So what you're going to do is you're going to add up each one of these angles at A, B, C, and D and set it equal to the sum of the interior angles. Now, if you don't remember what the sum was from the previous two problems that we worked on, okay, you can actually go ahead and use your formula n minus 2 times 180 and figure it out from there, okay? But your answer should be a whole number. X should be 18 degrees, okay? So I'll put that down there. X should be 18 degrees. So I will want you to go ahead and show me the work for that, and I'll give you that credit. For numbers 8 and 9, what you have here is two problems that deal with equations that we've had that came from that previous Word document that I just showed you, okay? So at the very beginning of this video, you had those what was it, 4 different equations, okay? And so in this first one, it says, okay, if the sum of all the angles is 8,820, how many sides does the figure have? You're going to have to manipulate the equation. Okay, so the equation in this case would be n minus 2 times 180. Okay, and you have to set that equal to the sum right here, 8,820. Okay, so you'll need to go ahead and solve for n there in that one. Number 9, if an interior angle, so an interior angle, so meaning one interior angle of a regular polygon measures 172.8 degrees, how many sides does the polygon have? Okay, well, you're going to use that formula, again, that I showed at the beginning of the period, n minus 2 times 180 divided by n, and you're going to set that equal to 172.8. Okay, so I'd like you to go ahead and finish those up for me, and then you have a couple of practice problems I'd like you to work on for the next time we are in class, and hopefully that was short, sweet, and understandable. Thanks for being a great audience, and we'll see you next time. Bye.